Yeah, ladies and gentlemen, my name is Jesper Andersen. I come from Niva, Denmark. I'm here to present some work I've done with my colleagues, Emilie Kallenbach and Karen Murray. Karen is the neat wizard. And we are dealing with biodiversity and eutrophication. Good. What are we talking about? Well, I guess you all know that eutrophication is about adding nutrients to a water body. We have primary effect, meaning accelerated primary production. And if this production is high enough, we have some very significant effect on benthic communities, as you can see with the Beautification. Eutrophication, it's a large-scale problem in Europe. This is a satellite map of chlorophyll A concentrations in surface waters, but you can see we have it in the Baltic, the North Sea, part of the Northeast Atlantic, in the Black Sea, and in parts of the Mediterranean. Okay, I'm a eutrophication guy, sorry, but I must admit that life is bigger than that. Biodiversity, or the eutrophication, and this part of the food web is not the full picture. When we're dealing with biodiversity, we need to take marine mammal, fish, and seabirds into consideration. We haven't published this yet. It is extremely interesting, but we needed, like this old fella, we needed to think about it and we needed to understand it, what it is about. And I'm really pleased to try to address these two questions. What are the potential management implications of assessing biodiversity status using a tool like NEET or other tools? And also the question at the bottom, can we have a good environmental status with respect to biodiversity in water bodies affected by eutrophication? There are so few synoptic studies of biodiversity status and eutrophication status, plenty of eutrophication by the way, but we have been able to find 3 studies, and my presentation is based on this. One study is a national one, it's the Danish 2012 MSFD initial assessment. We have a regional study from the Baltic based on the ecosystem health assessment of the Baltic Sea from 2003, and ta-da, we have a pan-European based on the testing of these. The national study comes from this, what used to be a dynamic center of Europe in terms of monitoring, it's no longer. We have assessed biodiversity on a national scale, and we have assessed eutrophication on a national scale. So we can make this comparison. When we turn to the Baltic, there are assessment of biodiversity and eutrophication using the tool. And again, we have the European study, the need-based tool, which has been published in this paper. And what we did, we simply turned off the biodiversity indicators and only kept the eutrophication indicators. Then we had a eutrophication assessment study as well. Okay. Look at these colors from the Danish study. Green is gas, yellow and red is non-gas. We have 22 assessment units. If the eutrophication assessment indicates eutrophied, the biodiversity status is not good. If we look into the Baltic, we have 9, but as you can see, up for the Botnian Sea, we actually have a ghost in the machine. We have a eutrophication assessment saying moderate. Somehow the biodiversity status is good. If we look into the boat study, we have the biodiversity assessment. When we turn off everything that is not eutrophication related, we have a eutrophication assessment. This is based on an average. If we use the one out, all out principle, we have a sort of secondary eutrophication assessment, and then we can compare. This is the Danish study with eutrophication at the bottom and biodiversity at the y-axis. There is a significant correlation. If we look into the Baltic, it's the same. And if we take the need-based study from the boats, turn off everything that is not eutrophication related, we get a result like that, which is also significant. Okay, to wrap it all up, we have carried out a meta study based on 3 synoptic studies of biodiversity status and eutrophication status. They vary with respect to scale, but the conclusion seems to be that if the area is eutrophied, you will not get a good environmental status with respect to biodiversity. So the question that was raised is, can we get guess for biodiversity when it's eutrophied? Apparently not. And the management implication is that the nutrient input needs to be fixed if we want to get guess for biodiversity. And that is a very, very important take-home message for managers. If you want to see a good biodiversity in your area, then your program of measures, if it's eutrophied or the eutrophication problem area, it needs to fix the nutrient inputs. That's it. Thanks.